In recent decades, access to electrical energy has largely depended on centralized infrastructure. Households are typically connected to regional grids, where energy is generated, distributed, and billed based on consumption. Alternative approaches, such as solar or fuel-based generators, exist, but they often require significant upfront investment, installation effort, or ongoing maintenance. Within this broader context, various independent systems have been proposed that aim to modify how energy is accessed or utilized at a smaller scale. These systems often take the form of instructional frameworks rather than finished products, requiring users to assemble components based on provided documentation. The Energy Revolution system is presented as a digital instructional package. It does not include a physical device. Instead, it provides a set of documents intended to guide the user through the construction of a small-scale electrical device. The core of the product consists of blueprints and schematics. These are accompanied by written explanations and a list of required materials. The structure suggests that the user is expected to source individual components independently and assemble them following the provided instructions. The design referenced in the documentation is associated with a bifilar coil configuration, historically linked to electrical experimentation. The product positions this configuration as the central mechanism within the system. The usage process begins with accessing the digital materials after purchase. The user reviews the documentation, which includes diagrams and step-by-step instructions. This initial phase is informational and requires reading and interpretation. Following this, the user acquires the listed components. These are described as commonly available electronic parts, typically sourced from hardware or electronics stores. Assembly is then carried out manually. The instructions outline how to connect and arrange the components to form a working unit. This process involves physical handling, basic assembly skills, and attention to detail. The total time investment is divided into 2 phases. Approximately 1 hour for understanding the documentation, and up to 4 hours for constructing the device. The system does not appear to require advanced technical certification, but it does require active participation and manual execution. Once assembled, the device is intended to be connected to an existing electrical context, where it operates as part of a broader setup. The documentation suggests continuous operation after installation, with minimal ongoing interaction beyond occasional inspection. This type of product aligns with individuals interested in do-it-yourself projects involving electronics. It assumes a willingness to follow technical instructions and to assemble components independently. It may also appeal to users who prefer instructional formats over pre-built devices. Since the product does not include physical hardware, it requires a degree of autonomy in sourcing materials and completing the setup. The level of effort involved suggests that it is not designed for passive consumption. Instead, it functions as a guided construction process, where the outcome depends on the user's ability to replicate the described configuration. Compared to conventional energy systems, the Energy Revolution system differs in format and delivery. Traditional solutions, such as solar panels or generators, are sold as physical products with defined specifications and installation processes. In contrast, this system is purely informational. Its value is structured around documentation rather than hardware. This places it closer to educational or instructional products than to industrial energy solutions. When compared to other DIY electronics guides, it follows a similar pattern: documentation, materials list, and assembly process. The distinguishing factor lies in the specific configuration it proposes and the conceptual framework behind it. As with other instructional systems, the outcome depends on execution. Variations in assembly, materials, and interpretation of instructions can influence the final result. For viewers interested in examining the original instructional material, the reference link is available in the video description.